Good day, my dear 9th class students. I am very happy that I get the opportunity to continue to teach coordinate geometry to you. Previously I taught lines and angles, that I finished. The next chapter is chapter 5, coordinate geometry. And in the previous part, that is part 1, I gave you all the details, how the coordinate system is represented on a piece of paper, on a graph paper. And I also told you some introduction. And prior to that, I want to say, I gave you made some general comments. I want to repeat them now. I hope you guys are watching the videos. We so far made more than 120 videos in different subjects for different classes. You have to continue to observe or watch the videos along with the textbooks. Then it will be more useful. So, with that assumption, we are proceeding ahead. That you have the textbooks. Unfortunately, of course, many of you do not have them. If you are borrowing from somebody, that's a different story. But you have to have your own textbooks. Now, without wasting much time on that, I want to move on to the actual teaching the coordinate geometry. I told you that this coordinate geometry was developed in the 17th century by a famous mathematician by name René Descartes, also known in a different language Cartesius, C-A-R-T-E-S-I-U-S, Cartesius, C-A-R-T-E-S-I-U-S. That is the mathematician's short name. Now, because he developed this geometry, coordinate geometry, the whole system is called Cartesian, just like India and Indian, Cartesian coordinates. The coordinate system, the whole system is Cartesian coordinate, let us say system, okay? He is the pioneer of this coordinate system, and the whole mathematics, all the space technology uses this coordinate system. In the previous class, I gave you some examples how to locate an object in the universe with the coordinate system. So it is very, very important. But here, in this class, we are going to limit ourselves to a plane geometry. That means it has only two coordinates, x and y coordinates. That means this is a plane. The boat you have here, this is a plane. So, plane geometry has x and y coordinates. Now, in the previous class, I mentioned about the x coordinate, y coordinate, and how a point is represented, things like that. That means if you take a graph paper, I'm just only summarizing a little bit, I'm going fast. If you take a graph paper and divide that into 4 parts, and you call this point is called the origin. This is x-axis, capital X. Now you cannot write small, that is a mistake. So you have to put capital X, and this is x dash. This is y, capital Y again. This is y dash. That means if you draw two lines perpendicular to each other, this is the point origin, O-R-I-G-N. This is x-axis. This is y-axis. The bottom portion is y dash or minus y. See, this is x, so this is x dash. Now, any point P any point P or M or Q or R, M has to be designated by two numbers. That is, let us say M23 or KXY. So the first number indicates the distance of the point along the x-axis, and the second number represents the distance of the point along the y-axis. Suppose you want to plot M23, that means you have to go 2 units. Let's say this is 1, 2, 3. I will say 1, 2, 3. This is, you have to go walk along x-axis 2 units, and then parallel to y-axis 3 units. That means this is your point M. That's I explained all that. I want to go rush through because I wanted to spend my time more on the problems. So M23, the first number represents the abscissa, x-coordinate. The second number represents the y-coordinate, and also it is called ordinate, abscissa, A-B-S-C-I-S-S-A, abscissa, and the y-coordinate is ordinate, O-R-D-I-N-A-T-E. Okay? Alright, abscissa and ordinate. So, if you say K 2.5 and 7.5, let us say, that means K, this is in the, if you draw 2 lines like this, and there are 1, 2, 3, 4, 5, 6, 7 like that, here similarly 1, 2, 3, 4, 5, this is 2.5, that means this is 2, 1, 2, 3, that means 2.5 is here, 1, 2, 3, 4, 5, 6, 7, 8, so there is 7.5, that is 7.5. So this is your point K. Now, I also told you this is x-axis, this is minus x-axis. So here this is minus 1, minus 2, minus 3 like that. Similarly, this is y-axis, 1, 2, 3, this is minus 1, minus 2, minus 3 like that. Okay? So given a point, it can be represented on a graph paper with the proper scale. You normally use 1 centimeter is equal to 1 unit, and based on that you can represent the point. Now here you can see, if you take a point here, this one is called the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. We go in the anti-clockwise direction. This is the anti-clockwise direction. So, in the first coordinate, x-axis is positive, y-axis is also positive. In the second coordinate, x-axis is negative, y-coordinate is positive. In the third quadrant means 1/4. Qua means 1/4. Quarter. So, quarter means 1/4. Quarter is 1/4. So here, second quadrant, in this y-axis is positive, x-axis is negative. That means here, if you put a line in, just a typical example, x-axis is negative, so minus 2, let's say y-axis 3. So x-coordinate will be negative, y-coordinate will be positive. Whereas in the third one, if both are negative, x-axis is negative, y-axis also negative. Let us say this is t is minus 3, minus 5, like that. Whereas in the fourth coordinate, x-coordinate is positive, y-coordinate is negative. That means this, let's say 2, I am saying u, 2 and minus 3. So, in the coordinate system, there are 4 quadrants, first, second, third and fourth. In the first quadrant, both x and y axis are positive, whereas in the second quadrant, x coordinate is negative and y coordinate is positive. You don't have to, this is not like a rocket science, you have to memorize, oh my God, and all that. No. Just to try a sketch here, it's simple, it's very, very simple. Draw a line like this. This is the origin O, this is x-axis, this is minus x. That means all from here, these are all negative, from here these are all positive. Similarly here, these are all positive and this is the negative. That's it. It's very simple. And depending on point here, this point, suppose I have a point here, x-axis is negative, y-axis is also negative. Whereas here, if I have a point here, x-axis is positive, y-axis is negative, like that. You can easily know that. And incidentally, this point, like I said, origin coordinates are 0, 0. Because x coordinate is 0, y coordinate is 0. Now, and also suppose you have a point like P, 0, 3. What does it mean? The x coordinate is 0, y coordinate is 3. That means here x coordinate is 0, y coordinate is 3. If you go 3 units, this is your P. Similarly, suppose I have R 5 and 0. Let us say R 5 and 0. That means x coordinate is 5. So you go 5 units here, and for y is 0. That means it lies on the x-axis. This is R. So where if the x coordinate is 0, the point lies on the y-axis. If y-axis is 0, y coordinate is 0, or ordinate is 0, the point lies on the x-axis. So here, having said all this, now if we go to the problem, first actually, as a matter of fact, I thought I would just like the previous chapter, where I selected some problems and I explained one after another. Here also I thought I would do that. That's why I said here exercise, page number and problem number. But I mean these are not very big, difficult problems. So each problem is different. So what I thought is I will select some problems at random right away on the spot, rather than initially fixing up these are the problems I am going to tell you. I am not doing that here. So it is simple. As long as you know, summary, this is the origin, this is x-axis, this is y-axis, this is minus x, or sometimes x dash we will put it, this is minus y or y dash, this is all positive, this is positive, here this is all negative, this is negative. Okay, as long as you know, this is the first quadrant, this is the second quadrant, this is the first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. As long as you know how the coordinates are, sorry. So as long as you understand the coordinate system, it's a piece of cake. It's not difficult. And also, in some of the exercises, we plot all these points. Sometimes you can make a building, or you can make a letter, or sometimes you can make a number. So, just by joining the various points. So here, for example, I would like to take the first, there are not many problems in the first exercise. Let me go through 5.2. Let me see what this is. Yeah, let us see 5.2. Write the quadrant in which the following points lie. First one I take minus 2, 3. This is 1. You have to put the bracket. So this is how you mark it. First you write the x-axis coordinate and then the y coordinate, and then you proceed with the parentheses. That's how you have to represent. Minus 2, 3, and then you have 3, 0, and then let us say 4, 2, like that. So you see, this one, which quadrant it is? X coordinate is negative and y coordinate is positive. That means this is the second quadrant. Right? This is negative, this is positive. Minus 2, this way 3. Up. So his point is somewhere there. Second quadrant. Similarly, 3, 0. That means x coordinate is 3, y coordinate is 0. That means it is on the x-axis. Okay? It is not in the quadrant, it is on the x-axis. Similarly, 4, 2. 4 is, this is positive, this also is positive. That means it is in the first quadrant. Understand? So what you do is, you represent these points on a graph paper, and immediately you can see that. write the abscissa and the ordinate of the following points. Abscissa and ordinate. Now, let's say the first problem is minus 5, 3. The first coordinate, first number is the x coordinate, or is also called abscissa, A-B-S-C-I-S-S-A. Right? 3. The second number is the y coordinate or ordinate, O-R-D-I-N-A-T-E. This is called the ordinate. So, when in the Cartesian coordinates, it's a universal law. The first number represents the x coordinate, the second number represents the y coordinate. Nobody can change it. That's a rule. Just like you see when you say 1 centimeter, that length is universally accepted. This particular length only is called 1 centimeter. Nobody can change it. Okay, no government can change it. Now next one. Which of the following points lie on the axis? You have to find out which points lie on the axis. Which points lie on the axis? Now I told you earlier, if the x coordinate is 0, that means it is lying on the y axis. If the y coordinate is 0, it is lying on the x axis. If none of them are 0, that means the point has to be in the either this coordinate or this coordinate, this coordinate or this coordinate, depending on the values, whether positive or negative. Okay, for example, I will take minus 5 minus 8. Minus 5 minus 8. That is one point. And another one I will take 7, 0. Another one I will take 0 minus 8. 0 minus 8. Now this one is minus 5 minus 8. Minus 5 minus 8. That means the point is here somewhere in the third quadrant. This is in the third quadrant. It is not on the either x-axis or y-axis. No. Now for example, this one if you take 0 and minus 8. X coordinate is 0, minus 8 is the point is here. That means the point is on the y-axis. Similarly 7, 0. X-axis 7, y coordinate is 0. That means it is on the x-axis. Okay? You got it? Okay. Now, write the following based on the graph. There are some points here. You have to write down what is the ordinate, what is the abscissa. That's a piece of cake. I don't think I need to explain that very well. Okay? You already know that. Now, the third exercise, if you go, third exercise, these exercises are fun. You can easily do it. I don't think you will have any problem. Of course, as usual, Srujana is always available, 365 days a day, 24 hours, 365 days per year, and 24 hours per day. Okay, that means all the time. It's you. The ball is in your court, my friend. Ball is in your court. You send the message, and we will tell you the answer. Okay. So the ball is in your court. Don't say that Tataya, I don't know this. I don't know how to do this, so I stopped it. No, don't stop anywhere. Move on. But whichever one you have a doubt, just send the message to us and make us work. Otherwise, we will see some movies and all that. Okay, make us work. So send the questions. So here in this exercise, he asks you to plot the point, and then join the points, adjacent points. You have to join all the points in an order and find out what shape do you get. Okay. Okay, I don't think I need to tell you any more here, but all you have to do is just mark the point. Suppose you have something like this, and you have a point here, you have a point here, you have a point here, another point here. If you join, then you may get a square or a rectangle or different shapes. You can see the different shapes here. So all you have to do is you have to plot the points and then join them by straight lines in an order. Okay? So, we are coming to end of this chapter 5. So again, once again, I told you a mathematician in the 17th century. His name is René Descartes. He is not, in short, you know as Cartesius. Because his name is Cartesius, the geometry he prepared or he developed is called Cartesian coordinate system. Now, this coordinate geometry is very, very, very important. Any object in the universe can be identified with certain coordinates, x coordinate, y coordinate, and also z coordinate, and some other parameters. We are not, like I told you, this chapter that you have now is only a plane geometry. That means everything is in a single plane. This is one plane. This is one plane. Now there is also three-dimensional geometry, and what is that? There are other coordinates also. There are cylindrical coordinates. Here we are talking about Cartesian XY coordinates. Sometimes you use the cylindrical coordinates also. They are not, but they are not in your syllabus. I think probably you may get them in intermediate, so not even in 10th class. So this finishes this chapter. I want you to do all those problems. Unless you do those problems, see, as soon as you hear, as soon as you watch the video, as soon as you watch the video, go to your, look at the textbook, take some graph papers, mark them, and solve the problems. Also, incidentally, I want to tell you, it will be very useful if you can create a graph paper. Maximum, I want to tell you, 2 minutes. I am giving you only 2 minutes time. You have to prepare a graph paper on a white sheet. That means if you take, I will show you here, if you take a 18 by 11 sheet, what I will do is, you draw a line here, draw a perpendicular line in the middle. So you can mark the middle, okay? Now, so here you mark 1 centimeter, 2, 3, 4, 5 like that. Similarly here 1, 2, 3, 4, 5, 6 like that. Okay, similarly here 1, 2, 3, 4, 5, 6. And here at the bottom also what? Mark the centimeter. That means you put a scale here, 1 centimeter, then now you can, with the use of a set square and all that, you can draw a line, lines parallel like this, lines parallel, okay? Similarly, here you draw lines parallel. You already prepared a graph sheet. You have to know how to prepare a graph sheet, because what happens is, in the 10th, well, we came to the end of the coordinate geometry chapter. One special situation where you may run into trouble of not having a graph paper. So in the 10th class examination paper, it's I was told that it will be a booklet, and you may not have, suppose you have given 2 graph sheets and one by mistake it was spoiled, so you should be able to generate a graph sheet. It's very simple. All you do is on the 18 by 11 sheet that you have, suppose you make a border like this, just to limit your graph to that, and then split this into 4 parts like this. Suppose you, whatever number, this is 0. Now here 1, 2, 3, 4 like that centimeter, and 1, 2, 3, 4 like that. Okay, similarly here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. You with a scale mark this point, and then using a set square and all that, you can draw a line like this, line like this, line like this, line like this. Okay, all right, got it? So similarly here, through that. Still, if you want to make it easy, you can mark 1 centimeter here, 1 centimeter, 1, 1, 1, 2, 3, 4. Then you can join these 2 lines and extend it, join these lines, extend it, join these 2 lines, extend it, join these 2 lines. Similarly here, this is 1, 2, 3, 4. You can mark here 1, 2, 3, 4, 5 like that. If you join these two and extend it, join these two, extend it, join these two, extend it. Similarly on the other side also, if you do that, okay, you use that, you have a graph paper. You should be able to do it maximum time. I am saying in Sujana, you have to be able to prepare a graph sheet in not more than 2 minutes. 1.5 minutes, you should be able to do it. That means you don't have to worry a graph sheet is available or not. You can construct it just like that. So basically you draw a margin so that you contain your graph sheet inside the sheet and then divide this rectangle into 4 equal parts. May not be exactly equal parts, and then mark all these 1, 2, 3, 4 like a centimeter here, centimeter here, centimeter here. Here also you can, from here, you can mark the centimeters and mark the centimeters. If you join them and extend it, you get all the vertical lines. Similarly here, when you are marking, here 1, 2, 3, 4, similarly you mark 1, 2, 3, 4 here. Join these two, extend it. Join these two, extend it. That's why you get a graph paper. That's how you can prepare a graph sheet, even if the given graph sheets are not adequate, or even one of the graph sheet is damaged due to some reason or other, you always have the graph sheet in your hand. So that's what it is. Okay? Thank you. I hope you understood how to make a graph sheet on your own. Thank you.